Hello there, I'm St-Pierre. This is a video for contributors, so developers that would be interested in contributing to StaticBackend actually. So what we will be covering in this video is how am I typically developing new features and fixing bugs and whatnot on StaticBackend. So this is a Go application. So I'm currently in the repository in the main branch. If you clone the project, you will be there. The first step when I'm starting development with StaticBackend is, well, what I like to do at least is start all the Docker services that I need. So for instance, so this is the core package that we were, and there is multiple Docker file. In fact, the one I'm using when I'm developing is I'm using the unit test one, because the unit test one do have both Postgres and Mongo inside of it. So that's really useful because I'm often switching between the two during development. So there is Postgres, there is Mongo, and there is a Redis server in there. So let's start our services with Docker Compose, and we will load this unit test file. So like I was saying, it will start all the services. If you don't have a Postgres database, well, the first time you will run that, it should run the first migration file, which basically creates the necessary table in Postgres for StaticBackend to work. So that means that well, it will need the UUID extension, and it will create the SB schema. So the SB stands for StaticBackend, and this is those are the table that are minimally required for the app to work. So there is a customers table and there is an apps table. So keep in mind that StaticBackend was a private SaaS at first, which I've open sourced almost 1 or 1.5 years ago. So it's now a fully free and open source project, but I'm still having this managed services for hosting. But yeah, that's why the table is called customers. Okay, so once I start my services, so everything should be fine for me to start developing. If you clone the project, the first step that you will need to do after running the services is clone the demo and env file. So this file have the minimum environment variables that you will need to do that. So just rename that to .env. So I will copy that. So let's copy to .env. So why are we doing that? Well, I'm using a makefile to run tests, to build the application and whatnot. And if we peek at this makefile, let's jump on my code editor. I think it will be easier. I will zoom in also, so to make sure that font size is fine. Okay, so why are we needing an environment file? Well, it's because we are grabbing all the environment variable in that file and sourcing them in the makefile. So if you are on Windows, I don't think you have an easy way to have make other than using the Windows subsystem for Linux. So that would be what I would do if I were on Windows. I would use WSL to make sure you have make available. So let's have a quick look in here. So there's a build function. There's a start. So that one is useful. This is how I'm testing things in in development and whatnot. Deploy is not really interesting for now, but there is a lots of small test helpers that just test specific package. So for instance, when I was building the Postgres package, I was using this a lot. So I did not want it to run all the tests because the tests are a little bit long to run. Let's run that. Let's run all tests. So I have a all tests in the make file. So make all tests. So they are not really unit tests actually. So they are more like oh yeah. Okay, let's back up a little bit. So we have an error with Redis and our database, in fact. So when I told you to rename the demo env file, well, there is a couple of things that we need to edit, because this file is in fact a demo for using the Docker version of of StaticBackend. When I'm in development, I am not using Docker to build StaticBackend. I'm building it directly with Go build, and I'm running it natively on my development machine. So you will need to edit this file quickly just to tell it, well, this will be localhost and the Redis in here will be localhost as well. So those were the hosts of the Docker file. So let's have a quick peek at the Docker file. Not really. Let's have a quick peek at the Docker Compose demo. So the Docker Compose demo is what I'm using on the documentation. If people would want to test StaticBackend, and let's say they don't really have Go already on their machine and whatnot, so they will prefer to build the app via Docker. So this Docker Compose demo goes end to end with the demo env. So that's why it's hard coded to have the DB host. And now I just realized that I did not edited the right file. Yeah. Let me close that. This is something related to Visual Studio Code, actually. I had this, how can I say that? I had this real env file that I'm using with some value, but okay, let's do that on Vim quickly. So what we want to do is edit the env file and change the host in here for localhost and the Redis host in here to localhost. Okay, so now we should be able to run our test. And like I was saying, they are kind of long to run because they are integration tests at the end of the day, because they are actually doing lots of things on the database. So that's mainly the two things you will need to do. So first, start the services from the Docker Compose -unit test. After that, copy the demo env file and do the changes that to change the host. And from there, well, at least you should be able to run the test. So that's the first step, I think. I think once you are able to run the tests, well, you should be more confident and comfortable to start, doing some kind of changes. So let's have a look at what do we have? What do we have in here? How the project is structured, and what things do what, in fact. So let me just do that a little bit. So basically, this is a Go application. I am not using any frameworks or library for for the web and whatnot. So this is using net HTTP. So let's have a quick look at each package quickly. So the cache package is using Redis at the moment. This one is certainly the next one that will need to have an interface created. So what I mean by that, well, the majority of the dependencies or the services that StaticBackend is using, for example, it can use MongoDB or it can use Postgres as well. So there is there is two implementation for those two database engine, and the way that you specify which database engine you want is in your env file, actually, which we saw earlier. So there is a data store which you can use PG for Postgres or Mongo directly, and this will tell the StaticBackend which implementation to use. The cache package does not have an interface yet. There is a hard requirement on Redis, and but yeah, it cannot be easily moved to an interface, because it will still require to split the caching mechanism and the pub sub mechanism, because let's say that someone would want to use something else than Redis. It does not. It might just be a cache. For example, they might want to use RabbitMQ, for example, and or I don't know, Postgres, for example. So the cache functionality and the pub sub functionality will have to be split. But yeah, let's continue our tour of this file. So those are like kind of simple function to get or set specific value into the cache. We can also increment and whatnot, and there is a pub sub down here that is used across the application to post messages. So we will see that later, but there is a pub sub involved with the caching. So this package is responsible for caching and pub sub at the moment, and unfortunately there is no interface for that. So the CMD package, well, it's very straightforward. The main file just call the start functionality of the main package. So the main package is back in here, and we can pass the database host and the port, and yeah. So that's fairly straightforward. So the database, well, we will not go into too much detail into this, but those two packages are extremely similar. In fact, I would say, well, file structure, and in terms of file, they are exactly the same. They are implementing exactly the same interface. So it's just implementation detail in here at the end of the day. But let's see. Let's see the interface that they are implementing. So this interface contains all the functions that StaticBackend needs to operate. So for example, when you first start the application, the static backend application, you will need to create a customer and an application, which is called a base here. It's mostly a database, for example, but you need to create that to start using it yourself. So all of the functionalities that is used by static backend is in that interface. It's a big interface, but yeah, it's yeah. There is probably a better way to do that. I don't know. Okay, let's continue. So email. So static backend can send email. So there is two implementation at the moment. So the dev implementation is just printing things to the console, and the SES is calling the Amazon simple email services. So again, this is an interface as well. So just like the database. The extra package is where I'm starting to have a little bit of how can I say that? Functionalities that do not really deserve their own packages. For example, resizing image. I'm also working on sending. Not sending, but I'm also working on the converting HTML page to PDF, for example. So those things will probably not need their packages. The function package is interesting. So there is a full runtime that static backend offers. So developers can write functions in JavaScript, and their function run into this custom runtime. And what this runtime is doing actually is it's creating functions that people can use directly into their own JavaScript function. I'm not sure it is very clear what I'm saying. Let's have a look at the test, for example. So there is a test for a function that someone would write. So those are server-side function, right? So you write a function, and your function needs to have an handle function in it. So it could have multiple function in your file, but the entry point is handle. And in here, you will, you receive as a developer the body of the request. There is other parameter like the query string and also the HTTP headers. So you can opt in to receive all of those things in your function. So functions are triggered either by a web URL or by an event. So they are topic based. So when a developer register a function with static backend, they have to either pick a topic. Let's say you want to run a server side function when one of your database table will have a new row, for example. So you could create a function that will react to this event, and yeah. And from here, what I was saying is that this function runs into a custom runtime. So the create function that we are seeing here, we are adding that to I call that a virtual machine, but I mean it's not really that, but it's a tiny virtual machine, but whatever. Fact is, so from JavaScript you are calling those function, and those function just call the the normal implementation. So if we were to use Postgres or MongoDB and whatnot, so we will at the end of the day call the data store, which is defined as as an interface, and we will call the right function. So suffice to say that there is a runtime to execute functions. So they are not fully they are still sandboxed and whatnot. So this package handle all of that, and yeah. So where were we? So the internal package where there is some very tiny thing in here, mostly structure that the rest of the application uses. So, you know, internal stuff. Well, middleware is where things get a little bit interesting, probably because they are used very early in the pipeline. Of course, they are middleware. So there is one requirement when calling static backend endpoint, and it needs to have a public key. So a static backend public key, and this tells the system or static backend which database, which app we are targeting. In fact, so this is required. So that's the first middleware that is encounter. There is the authentication database and middleware, and there's also the root token, which is also in the auth file in here. But there is a couple of middleware. We will not. The real time is everything that relates to WebSocket and whatnot. For now, static backend is using server-side event. So basically, the server can push data, but the client is still using HTTP post. But under the hood, I mean, nobody really can tell that it's like that. It's like that for a reason, because the real WebSocket implementation I started, I had some issues, and yeah, for now it's using server-side event. Resources. Oh yeah, okay. Yeah. So the resources are for the web application. So when you run the application, there is a web UI that come with it. So it will be the same for the template. So storage is again, it's driven by an interface, and there is two implementation. There's one for Amazon S3 and one for a local file, and the templates are, like I was saying, for the admin web UI. So everything in the root package is related to the web application. So the server.go is probably the most important file when getting started, because this is where all the routes are defined and whatnot. So let's have a look at the DB routes, for example. So yes, standard stuff. So we are chaining all our middleware. So I've created like slice of middleware that are reused. I don't really want to go into too much detail in here, but suffice to say that there is the server.go, and most of the resources that static backend is handling have a corresponding file. So database, sending email, things like that. So from here, that's mostly the tour of the application from a code perspective. So let's return to our, how am I, what is my day-to-day with it? So again, we have this Docker compose that started all our services. We ran our test in here, and when I want to you know to have an instance, I use the start make command, and now I have an instance at localhost 8099. So this is where you would create your application or log into the admin dashboard, for example. So let's do that. Since we are in development, I can create anything in here. It will not send any email because we are in development, and we saw that there is an implementation of the email interface that just prints things to the console. So the important part that you need is the static backend key and your root token. Those things are kind of important. And what I was going to say. Yeah, okay. So once you have that, so one other thing that I typically like to do is having a look at the database, for example. So if you do a docker exec with core db, and we will run PSQL. So the username is Postgres, the password is Postgres as well. So like I was saying, there is an SB schema, and yeah, this is the table that yeah, I'm losing my word, I'm sorry. This is the table that static backend needs to operate. If you have a look at all the database that or apps that were created, so we can have a look at that thing, and well, more interestingly, I think, is grabbing the name of the database. So this name is when we just created the application, it created an entries in this app, and this is actually a Postgres schema. So if we do, if we look at all the tables that this schema have, then we can see that static backend created tables automatically. So those are all reserved table names that static backend needs to operate. So each application have its own schema, and all schema will have all the same table inside that. So SB account and SB tokens are where user accounts are created. So an account have multiple tokens. So a tokens is just a user, in fact, with an email and a password, and the rest of the table are fairly descriptive. But yeah, if you need to debug something, you can connect to the database like that. Yeah. So I'm not sure if I want to go further for that. I think for a first introduction to the project, I think this is fine. So let's just try to log in, for example. So we could do, so like I was saying, you still need to have a public key on your HTTP header always, and we will post to the login endpoint. The login endpoint wants an email and a password. So this is our endpoint login. Yeah, don't remember what was the email. Let me have a look. Yeah, it's anything.com, and this is the password. So what I did, yeah, I think I did not use the proper all right. Cannot resolve proxy post. Right. It's capital X. Invalid. Page character. Yeah. Content type. Yeah, that was not glorious at all. It's very early in the morning at that, so that's my excuses. So we still need to post JSON, and damn. And then after, yeah, I should have prepared that. Oh yeah, it's the closing email in here. All right, finally we have a authentication token. So yeah, it was very long. I'm sorry to have wasted your time on that. The point is, so now from here, well, you have a complete working static backend implementation locally. So you could start writing some code, creating a branch, submitting pull requests and whatnot. Make sure you join the Discord channel if you want to discuss anything that you would like to work on. Yeah, there is a lot to do with the UI. Actually, there is also a complete CLI. There is client library in Go, Node, Python is coming soon, and the client side JavaScript library. So yeah, that's mostly it. Thanks.